Welcome to this brief introduction tutorial. This time we're going to talk about the EIGRP, which is one of the dynamic routing protocol. It was first proposed by Cisco, and yes, of course, this is also a Cisco proprietary protocol. Before we zoom down to what is the EIGRP, we will have to know what is the EIGRP, because the E here means enhanced. And EIGRP is what we call the interior gateway routing protocol. So EIGRP is an advanced version of the EIGRP, and it is also a distance vector routing protocol. You might put a question mark here, and what the hell is the distance vector routing protocol? Don't panic, I will explain in the future lectures. And later, we will focus on the topics like the basic configurations, and it's simple and easy to understand. And it is commonly used in the smaller networks. So there are some features I would like to highlight here. The EIGRP provides the rapid convergence and the higher scalabilities and support for multiple routed protocols. So the EIGRP can fulfill the requirements in a complex network environment. In the future lectures, I will cover all these features that I mentioned above to help you understand the concepts, like what is the scalability means here, and what the hell is the convergence here. So no worries. This is routing. There's nothing difficult in the CCIE study. There is a complex diagram here. Maybe it just looks a little bit confusing, but I tell you, it will not be that difficult, because it will become very easy. Thank you if you just follow me tightly. But first of all, I'm the lecturer, or you can say a presenter, and these slides are prepared by my colleagues. Thanks for the nice job. We assume that you have a basic knowledge of other dynamic routing protocols. For example, the RIP, which is RIP, the Routing Information Protocol, and the OSPF, and whatever. So one of the best way to learn the EIGRP, just from my personal point of view, is to do the parallel comparison, because we've learned already the for example, the OSPF is a link state routing protocol, while the EIGRP, as I mentioned before, is a distance vector routing protocol. We can understand the EIGRP with the help of the previous studies. And here list out some main features you might know, or probably you might not know. What is the partial updates, and how does the EIGRP achieve the load balancing even for the n=+ pathways? If you know, good. If you don't know, that's the reason why we're here, and what we're doing now. We'll learn to how to establish the EIGRP neighbor relationships, and how the EIGRP topology table being built, and how we can control the EIGRP behavior, and further we will touch on the applications in the IP version 6 environment. There are a lot of advanced features and functions in the EIGRP. I like EIGRP very much. In our later videos, we would like to give you more details on those key technologies of EIGRP, like the neighbor discovery, and the RTP, which is the reliable transport protocol, and the dual finite state machine. And by the way, The dual finite state machine is extremely important because this is how EIGRP can ensure a 100% loop-free environment. So yeah, and also the PDMs. Actually, for now, I'll just give you a full image of the EIGRP and what we're gonna learn in the next video series. And in the EIGRP database, 3 tables are used to describe the network topologies and the routing informations. First one is the neighbor table. You can find the next hop routers and outbound interfaces in the neighbor table, and which correspond to each. These are some what we call the relations for the directly connected routers running the EIGRP. And here are some terminology, and AD here is called administrative distance, while the IFD is the feasible distance. When you're watching this video, you can just pause for a second and read the definitions, and so I will skip this. Let's move on. The neighbor table will only record the directly connected devices and the agency information. So the EIGRP also combine all these components into a whole, which is the topology table. And based on the topology table, the CPU can do a calculation quickly and easily to come up with the optimal path for each destination, which is the best route. And also, you can read through the example later by yourself, and this example will wrap up this short briefing video, and I will stop here, and I hope you find them informative. If you want to learn more, it could be easier to join us. Thank you.